Hello friends, welcome to my channel TutorASRumale. Kindly subscribe my channel by clicking on the subscribe button, and then don't forget to click on the bell icon so that you can get the continuous update on the new uploaded videos. Okay, I'm very thankful for all the subscribers who subscribe my channel, and welcomes all of you to my channel. Hello, I'm Dr. Aniruddha Suvarnaprabha Subhash Chandra Ramale, right now working as an associate professor and HOD at GHRCM Wagadi, Pune in Computer Department. This video is about the innovative teaching learning practices that we are using at GHRCM. Actually, I'm having this my YouTube channel, TutorASRumale, and through this YouTube channel, I'm actually uploaded many videos. But one day, this came into my mind. Why not to upload the presentations recording of the students? So, what I did for machine learning, I especially have given these topics to the third year students where to the class which I am teaching this machine learning right now, and these are the topics that I have given. There are total 75 students, and ask them uh, to create the presentation, that is student must create presentation on the listed topic and record it using OBS Studio or Microsoft Expression. The recorded video must be uploaded to Google Classroom that we are having on title page of presentation. So few of the students who comply with this presentation video creation, they actually uh, uploaded this video on the Google Classroom and somehow given those videos to me directly on the pen drive. So what I decided after seeing this video to combine all those video into one video and upload them for what we call as evaluation to the world. So maybe because the videos are actually recorded by the students many times what does they create this presentation in hurry, and sometimes they may not use the proper English because some students have used Hindi and Marathi language also while explaining the machine learning. My request is to all of you that you kindly evaluate the content of each video of the student and kindly give some comments on it. Okay, your comments, whether positive or negative, okay, are always welcome. Just don't. That's what I require. And instantly, don't forget to subscribe my YouTube channel TutorASRumale. I myself are going to upload the complete tutorial on machine learning. Right now, we are very busy in MBA process of the department, so I'm not getting sufficient time to create a thorough video on machine learning. So maybe in the month of April and onwards, I will upload the entire machine learning course on TutorASRumale. Till then, I'm requesting you to subscribe my YouTube channel TutorASRumale, evaluate my students' presentation, and if there is anything wrong in presentation, anything, some small mistakes or something, kindly point out them. If there is something good in the presentation, kindly point out them. Okay, so here are the presentations given by the students. Okay, none of these presentations are actually of mine. Every presentation have the student's name, his photograph, and something like that. Okay, and all those are, I just combine this with this video. Thank you very much for visiting TutorASRumale. And once again requesting all of you to subscribe it, share it, and don't forget to click on the bell icon for new videos. Thank you very much.
To explain TAE2, which is PPT presentation on support vector machines. Content of this PPT presentation: what you should know about SVM. Example on SVM: the process of relating the two classes with hyperplane. Identify the right hyperplane scenario 1 and scenario 2, kernel trick, then SVM kernel function, pros and cons associated with SVM, then application and references. What should you know about SVM? SVM means a support vector machine. It is a supervised machine learning algorithm which can be used for both classification and regression challenges. However, it is mostly used in classification problem. In the SVM algorithm, we plot each data item as a point in an n-dimensional space where n is the number of features you have, with the value of each feature being the value of particular coordinate. Then we perform the classification by finding a hyperplane differentiates the two classes very well. Support vectors are simply the coordinates of individual observation. The SVM classifier is the frontier which best segregates the two classes, hyperplane or line. Here I am going to explain example. If we only had two features, height and hair length of an individual, we first plot two variables in two-dimensional space where each point has two coordinates, which is known as the support vectors. Now we will find some line that splits the data between the two differently classified groups of data. This will be the line such that distance from the closest point in each of the two groups will be farthest away. Here we show two plots, which is on x-axis is heights and y-axis hair length. Um, in second plotting we explain that there are two hyperplane lines at a point A which has a distance 2 unit and 15 unit, and at point B which is a red line hyperplane line which is as a distance 1 unit. The process of segregating the two classes with a hyperplane. Identify the hyperplane scenario first. Here we have three hyperplanes A, B, C that identify the right hyperplane to classify the star and circles. You need to remember a thumb rule to identify the right hyperplane. Select the hyperplane which segregates the two classes better. In this scenario, hyperplane B is excellently performs this job. Scenario 2, use the previous thumb rule, to identify the right hyperplane. Some of you may know selected hyperplane B as its higher margin compared to A, but here is the catch. SVM selects the hyperplane which classifies the classes accurately prior to maximizing the margin. Here hyperplane B is a classification error and A is a classified all correctly. Therefore, the right hyperplane is a A. Then we use a kernel trick as a SVM classifier. It is easy to have a linear hyperplane between these two classes. But another burning question which arises is, should we need to add these features manually to have a hyperplane? No, the SVM algorithm has a technique called a kernel trick. The SVM kernel is a function that takes a low dimensional input space and transform it to higher dimensional input space. That is, it converts the not separable value into separable value. It is mostly useful in non-linear separation problem. Simply put, it does some extremely complex data transformation, then finds out the process to separate the data based on the labels or output you have defined. When we look hyperplane, the original input space looks like a circle, which is shown in a below plotting. SVM kernel functions, that is radial basis style kernel function and neural net style kernel function. Beyond the polynomials, there are other very high dimensional basis functions that can be made practical by finding the right kernel function. Pros and cons associated with the SVM. Pros and cons associated with the SVM. Pros: it works really well with a clear margin of separation. It is effective in very high dimensional spaces. It is effective in a case where the number of dimension is greater than the number of spaces. It uses a subset of training points in the decision function. called support vectors, so it is also memory efficient. Cons of SVM: it does not perform well when we have large data set because the required training time is higher. It does not perform well when the data set is more noise. Target classes are overlapping. That is, target classes are overlapping. SVM does not directly provide probability estimates. These are calculated using an expensive 5-fold cross validation. It is included in related SVC method of Python scikit-learn library. Application: face detection, text and hypertext categorization, classification of images, biometrics, bioinformatics, protein fold and remote homology detection, handwriting recognition, generalized predictive control, and finally references. Thank you guys.
My name is Yogesh Pachange. I will teach you the random forest in Yum. I am pursuing engineering at Hierarchical College of Engineering and Management, Pune. Let's get started. Introduction of random forest. What is the introduction of random forest? Random forest is a supervised learning algorithm which is used for the both classification as well as the regulation. Both, however, it is mainly used for the classification problem. It is mainly used to classification problem. We know that forest is made up of tree and more tree means more robust forest. Similarly, random forest algorithm create the decision tree on data sample and then get the prediction from each of them and finally select the best solution by means of the routing. It is an assembly method which is better than the single decision tree because it is reduced the overfitting by the averaging the result. What is the random forest? An assembly classifier using many decision tree models can be used for the classification or regression. Accuracy and variable important information is provided with the result. Working on a random forest algorithm. There are many steps of working of a random forest algorithm. We can understand the working of a random forest algorithm with the help of following steps. Step number 1. First, start with the selection of a random sample from a given dataset. Step number 2. Next, this algorithm will construct a decision tree for every sample. Then it will get the prediction result from every decision tree. Step number 3. In this step, voting will be performed from every predicted result. Step number 3. Perform every predicted result. Step number 4. Last, select the most odd prediction result as the final prediction. That means the odd can be collected, then the final result prediction the result. The following diagram will discuss its working. All are the working of the random forest algorithm. See the working of the random forest algorithm. All are the working of the random forest. Random forest classification. There are the in this classification use the X dataset. Use the X dataset. N number of X dataset. N1 is the one feature, N2 is the second feature, N3 is the third feature, and N4 is the fourth feature. There are the three classes: Class C, Class D, Class B, and Class C. The fourth class will be majority voting. Then majority voting will be considered as a final class. Prawns of the random forest algorithm. Prawns. The following are the advantages of random forest algorithm. It overcomes the problem of overfitting by arranging or combining the result of different decision tree. Random forests work well for a large range of data items than a single decision tree does. Third one, random forest has less areas than single decision tree. Fourth one, random forests are very flexible. Random forests are very flexible and process very high accuracy. It can be used very high accuracy. Hmm. Random forest algorithm maintain good accuracy even the large proportion of the data is missing. Cons. The following are the disadvantages. Disadvantages of random forest algorithm. First one, complexity is the main disadvantages of random. It can be used the complexity of disadvantages of random forest algorithm. Construction of a random forest are much harder than time consuming than decision tree. More computational resources are required to implement the random forest algorithm. More resources are required to implement the random forest algorithm. It is less immunity in case when we have a large collection of a decision tree. The prediction process using the random forest. Prediction is the most important part of the random forest algorithm. Random forest analysis in AML and when to use it. First one, in machine learning, the random forest algorithm is known as the random forest classifier. It is very popular classification algorithm. It is used a very classification algorithm. One of the most intersecting thing about this algorithm is that it can be used as both classification and regression algorithm. The random forest algorithm is an algorithm for machine learning, which is forest. We know the forest consists of a tree. The tree being the mentioned here are a decision tree. Therefore, the random forest algorithm comprises a random collection of a forest tree. It is an addition to the decision tree algorithm. So basically, what a random forest algorithm does it that they create the multiple decision tree and merge them together to obtain a more stable and accurate prediction. In general, the more tree in the forest, the some robust would be the prediction and thus higher accuracy. A general purpose of the random forest is the classifier, then the decision tree and multiple decision tree and merge them together obtain a more stable and accurate the prediction. When to use the random forest analysis. First one is the banking sector. Banking sector is the most important used to random forest analysis. Banking sector consists of most user. Banking sector consists of most user. There are many local customer and also fraud customer. There are two different type of customer. Loyal customer or fraud customer. Every bank use there are different customers. Medicines. Medicine need a complex combination of specific chemical. Medicine use the complex combination of specific chemicals. Stock market. Machine learning also play a role in the stock market analysis. When you want to know the behavior of the stock market with the help of random forest algorithm, the behavior of the stock market can be analyzed used to a random forest analysis. E-commerce. E-commerce use the random forest algorithm also. When you will find it difficult to recommend it or suggest what type of product your customer should see. This is where you can use a random forest algorithm. E-commerce means the customer what want to know, customer suggest the thing. This is where you can use the random forest algorithm. All are the random forest algorithm in the machine learning. Thank you.
Hello friends, my name is Venkatesh Champagne Silvar and today I am going to discuss hierarchical clustering, and I'm pursuing my engineering at TutorASRumale College of Engineering and Management. Okay, let's get started. So uh, for for discussing hierarchical clustering, we should know about what is clustering. Clustering is a grouping of records observation of a similar object. As you can see in the following image, there are two groups. One is at the left side and one is at the right side. One is of the left side having one group, and one of the on the right side make a one group. The group is known as the different two groups are known as clusters. A cluster is a collection of records. The Yeah, that's why I'm saying it is a group of records. It is similar to one another. That means the dots which lie in the red cluster having the similar properties to one another, and the dots that are lying in the blue cluster having the same properties. But here one thing is to be noted, that red cluster having a different properties than the blue cluster, so they are dissimilar. Okay, now here we have another example of clustering. We have the some groups of dots lies on the slide. One of the group is on the right side. This is one cluster. One of the group on bottom of the page. There are the two clusters, and one of the group on the left side. This is one another cluster. Okay, so we are coming to our main topic, hierarchical clustering. What is hierarchical clustering? Hierarchical clustering, also known as hierarchical cluster analysis, it is an algorithm that groups similar objects into groups called cluster. As we have seen in the last slide, it uses an algorithm that creates groups of the similar objects and make a record from them. The record is known as cluster. Okay, the endpoint is a set of clusters where each cluster is distinct from each other cluster. That means it having a different properties from one and other clusters. So the objects within the each cluster are broadly similar to each other. So as we have already discussed the dots which are lie in the same cluster having the same properties. Hierarchical cluster can be performed with raw data. When raw data is provided, the software will automatically compute the output. That means when we give a raw data, that means non-labeled data, it will create output. We don't need to do anything. So after we have discussed the hierarchical clustering, then we are going to see how hierarchical clustering works. That means in what method it uses for clustering. So hierarchical clustering start by treating each observation as a separate cluster. That means a single dot represent one cluster in it. So we have two steps to create a hierarchical clustering. Identify two clusters that are closest to each other and merge them. Merge the two most similar clusters. This continues until all the clusters are merged together. It is illustrated in the following diagram. As you can see on the left side of the slide, one picture having the several dots. The blue dots are close to each other and they having the similar properties, so they will merge and make a one cluster. In the second diagram you have seen that cluster, After that, the one dot and the one big dot is close to each other, so they make a cluster. It will execute it until we get the largest cluster. So thereafter, the output of the hierarchical clustering is dendrogram. So what is dendrogram? A dendrogram is a diagram that shows the hierarchical relationship between the object. What is the object here? The object is here A, B, C, D, E, F, G. Okay, and it is a most commonly used approach to find out the output. The main use of dendrogram is to work out the best way to allocate objects to the cluster. The dendrogram below shows the hierarchical clustering of 6 observations shown on the scatter plot to the left. As you can see, this is a left image. We having a dendrogram structure, tree-like structure. It also called as dendrogram. Okay, then after we have a dendrogram structure. The singleton sets that we are seeing here are known as singleton clusters. When we merge them together, they are known as clades. Okay, then after, there are two types of hierarchical clustering methods. One is agglomerative clustering, and second is divisive clustering. Agglomerative clustering is a bottom to up approach. That means we go from singleton cluster and merge until they make one large cluster. So beginning with the singletons, we are started with the A, B, C as individual clusters. Then after merging them until we have achieved as the input as a root. That means we merge them until we get a single large structure. Okay. Then after, in each step, the two closest clusters are aggregate into a new combined structure. As you can see, their three clusters are very close to each other, so they merge and make a one cluster. Then after, eventually all records elements are combined into single huge cluster. So you can see in this slide, in the last step they all merge together and make a final dendrogram. Okay, it is most common approach. As you can see, it is very easy, so it is very common approach. Then after, we have a divisive clustering. It is a top-down approach. It is very similar to bottom-up approach, but having some dissimilarity between them. All records are combined into one big cluster. Here we combine all the cluster into one cluster. Then we differentiate more dissimilar records and separate until we get singleton set. It does not require k number of set in advance. As you can see in the diagram, we have a cluster, a huge cluster on the top of the tree. Then after, we split it into three groups, and they after that it will again divided into some groups, and we will get at the singleton cluster at the end of the tree. That means here we can observe that agglomerative cluster is bottom-up approach, and the divisive clustering is a top-down approach. Okay, there are some advantages and disadvantages to the clustering. So first advantage is we do not need to specify the number of clusters required for the algorithm. That means we don't require to give a number of clusters to the algorithm. It will find the number of clusters itself. Second, hierarchical clustering is easy to implement. As you can see how easily we are implementing the clustering, so you can easily implement the clustering. And third, the dendrogram product is very useful in understanding the data. So as you can see, it is very useful in understanding the data. You get the right knowledge in very less time. There are some cons to the hierarchical clustering. Most hierarchical clustering software does not work with the values are missing in the data. That means you need a complete output. Uh, half output have is is in the cluster, not make any output. Algorithm can never undo what was done previously. That means if you done anything wrong, you not able to do any able to do that thing again. The time complexity of at least 0 n square log n is required, where n is the number of data points. That means it is a very taking very large time to find the output. Sometimes it is difficult to identify the correct number of cluster by the dendrogram. Yeah, when you have got a many number of clusters, so it is difficult to find out how many cluster we get from the dendrogram. So that is a little information about hierarchical clustering. You can go through the references, that is Wikipedia, scikit-learn, or towards the data science for further more information about hierarchical clustering. So thank you guys for discussing with me about hierarchical clustering. Okay, thank you.